So we're going through the questions of the geometry test. Question 1. Question 1 has 14 points. We're given 1 point, 2 points, 3 points, line L1, line L2, and a plane. This is the equation of a plane. These are the parametric equations of the lines, and these are the coordinates of the points. So question A says, show that point C is in the plane pi. We know that when a point x, y, z belongs to a plane, that means that when we insert the point x, y, z in the equation of the plane, we need to get something that is true, which means that if our plane is x minus 2y plus 2z is equal to 4, and we insert the coordinates of C, 0, negative 1, 1, we just have 0 is equal to negative 2 times, minus negative 2, 0 minus 2 times minus 1 plus 2 times 1 is equal to 4, which is always true. Therefore, the point 0 minus 1, 1 belongs to the plane. Question number 2. Show that the line L1 is parallel to the plane pi. So, we need to show that a line is parallel to a plane. This is our plane, and we've got a line. We need to check if this line is parallel to the plane, which means that the distance at any point of the line is always the same to the plane. How do we do this? Well, we know that the normal vector of the plane is always perpendicular to the plane. This is the normal vector, characteristical vector, has many names, but we usually call it normal. And we know how to find the normal vector of a plane. If the plane is, the equation of the plane is x minus 2y plus 2z is equal to 4, the normal vector of plane pi is 1, negative 2, 2, which are the coefficients of x, y, and z. That is the purple vector, and we need to make sure that the red line is parallel to the plane. If the red line here is parallel to this plane, that means that the normal vector has to be perpendicular to the direction of the line. We are using line L1, and the direction vector of line L1 is 2, 3, 2, which means direction vector of line 1 is, what did I say? 2, 3, 2. 2, 3, 2. Which means that these two vectors have to be perpendicular. Are they perpendicular? For checking if two vectors are perpendicular, we need to use the dot product or the scalar product. It has two different names. The dot product says that 1 times 2 plus 3 times minus 2 plus 2 times 2 will be equal to 0 if they are perpendicular. And that means 2 minus 6 plus 4 is equal to 0. Therefore, they are perpendicular. So the normal vector of the plane is perpendicular to the direction vector of the line, and therefore line is parallel to the plane pi. Here we know that it's 0 because we're using in the dot product, the second part of the formula has the cosine of the angle between the vectors that we're evaluating here. And this 0 comes from cosine of 90, and cosine of 90 is equal to 0. For question C, we've got distance between line and plane. Can go back to this thingy here. If we if we look at this, we know that the line is parallel to the plane, and there is no formula for finding the distance from a line to a plane. So we have two different approaches. The first approach would be a geometrical approach. So we take a random point on the line and we project that point on the plane, and then we find distance from one point to the projection of the point. But that is too long if we're only looking for the distance. So what do we do when we only need to find distance? We know that all the points on line L1, all the points here have the exact same minimum distance to the plane. So we just need to use a random point on the line for C. For C, we just need to use a random point on the line, and we're talking about line 1 and plane pi. So we have 1 point there, 1, 1, 1, and the same plane as before. So using all that information, we know that the distance from L1 to plane pi is the same as the distance from 1, 1, 1 to plane pi. And there is a formula for distance point plane. When we just use the formula, we just need to write 1 minus 2 plus 2 minus 4 in absolute value divided by the magnitude of 1 squared plus 2 squared plus 2 squared. Well, that 2 here is not exactly a 2. It's more -2 than a 2 here, but we don't care because we're squaring it. So it's -2 squared, which is the same as 2 squared. This is just equal to 3 over root 9, which means that the distance is equal to 1 unit. For question D, we've got find the coordinates of the point of intersection of lines L1 and L2. So if we need to find the intersection between L1 and L2, let's just bring the equations of the line here. We've got question D. What do we do? When we have an intersection of two lines, this means that this point, which is the output of one point in this line, has to be the same as this point, which is the output of the other. And that has to happen for certain values of S and T. So what we actually need to do for finding the intersection point of two given lines is solve the system of equations that has this 6 equations. But we don't need to use a system of 6 equations. We can just write that equal to that. We can then write that equal to that, and finally that equal to that. When we do this, we get 1 plus 2t is equal to 5 plus 5s. 1 plus 3t is equal to 6 plus 7s. And 1 plus 2t is equal to minus 3 plus s. This was a calculator paper, so we don't need to do this without calculator. When we solve this, we write solve, we insert the equations, comma, s, comma, t, and we get s is equal to -2 and t is equal to -3. Once we've got these values, we need to insert these values, these s in L2 or the t value in L1. These will give us the coordinates of the point, and the coordinates of the point intersection are -5, -8, -5. Finally, last question is a bit more tricky. Find the acute angle between the line L1 and the plane pi. So first, the explanation A, B, C, D, E about how to do this. We've got a plane, same as before, right? And we've got a line, not the same as before. And this line and this plane describe an angle after the intersection. right? So we need to find that angle. But that angle is a bit difficult to find. We don't have tools if we don't go to trigonometry. So the easy approach here is using a vector that is perpendicular to the plane. Remember, the normal vector to the plane. And if we get that vector and the direction vector of the line, we can easily find the angle between the line and the normal vector to the plane. Of course, when we do this, we will find beta and not alpha, because we're finding the angle between the line and the normal to the plane, and we want the line to the plane. So once we've got beta, we need to do 90 minus beta to get the value of alpha. 90 minus, or the angle minus 90. There's the two angles have a difference of 90 degrees. So how do we do this? Well, we need to use, let's see what are the numbers we've got here. We've got to use the direction vector of the line, 5, 7, 1, and the normal vector to the plane, 1, minus 2, 2. So using the formula of the angle between two vectors, which is the scalar product, the dot product, formula states cosine of the angle is equal to u times v over the magnitude of u times the magnitude of v. I just said a different way. This means ux times vx plus uy times vy plus uz times vz divided by, well, the two magnitudes, magnitude v, magnitude of u. In our case, cosine of the angle will be equal to 571, as we said, times 1, negative 2, 2, divided by the square root of 5 squared plus 7 squared plus 1 squared times the square root of 1 squared. Again, the same issue with the 2. It's a negative 2, but it will be square. We can write it positive. And when we solve this with the calculator, we just get, first we press enter and then we do our cosine of the value for getting the angle. We get that alpha is equal to 105,63 degrees. But this is a bit weird because it's above 90, right? So we're actually not finding the angle that we were looking here for, not that beta. The one we're finding is, let's go back here, the line goes under the plane, right? And the angle we just found in green again would be the one that goes until that place under the plane. So we need to find the alpha angle, and the alpha angle has a difference here, like these 90 don't count, and if we just take this part of the angle, we'll get the same as alpha. If we see the perpendicular situation, we've got this is the plane, and this is the line. We found from the normal vector, we found that angle, and we only needed this angle or this angle, so we just have here 90 degrees that we need to get rid of. So we just need to do 90, the angle we found, 105,63 degrees minus 90 degrees will give us 15.63 degrees, which is the angle between the plane and the line. And that finishes with question 1. Okay, question 2, 6 points, has 2 parts. Part number 1, part number A, part letter A. In a space with orthonormal system of axes, consider the line L and the points P and Q. A. Let M be the line that passes through P and Q. Find the relative position of the lines L and M. Explain your answer. So we've got the equation of L there. We need to find the equation of line M, for which we will just write x, y, z parametric equations. We need the coordinates of one point that are 0, 1, 2, and then, not 0, 1, 2, that's the other line. 5 to negative 1, for example, 5 to negative 1. We can use either 5 to negative 1 or point Q 3, 1, minus 1. But now we need to find the vector that goes from P to Q or from Q to P. That vector is 2, 1, 0 when we find it. So we just get plus 2s plus s and plus 0s, which is just z is equal to negative 1. So now we've got the first line here and the second line. We need to find the relative position of the lines. Two lines can be, the first thing we need to check is if the direction vectors of both lines, that's one direction vector and that's the other direction vector, are these two direction vectors proportional? If the vectors are proportional, then we can have either the parallel lines or coincident lines. So vectors, in this case, vector 1, negative 2, 3, and this is the direction vector of line L, and vector 2, 1, 0, which is the direction vector of line M, are not proportional because 2 divided by 0 is not equal to 1 divided by negative 2 is not equal to 0 divided by 3. These three things have to be the same when two vectors are proportional. And if we get 0 divided by 0, we don't need it. It's not important because the coordinate will be 0 in both vectors. So this means that the vectors are not proportional, which implies that lines are either skew, which means one line goes there and the other line goes in a different direction. They can be skew, so they won't intersect, or they can do intersect at one point, depending on the situation we've got. How do we differentiate these two things, these two cases? We just need to solve the system of equations of M and L. So basically, we try to find the intersection point. To find the intersection point. If there is an intersection point, then they will be intersecting at that point. When there is no intersection point, there will be skew. Okay? Given that this is a calculator paper, I don't think we need to do this. We've got that line and we've got that line. So we need to solve the system of simultaneous equations that includes both lines, which means t would be equal to 5 plus 2s. 1 minus 2t would be equal to 2 plus s, and 2 plus 3t will be equal to negative 1. When we try to solve this, we can use a calculator. We'll get that there is no solution. Therefore, lines are skew in this case. That was question A. Let's go to question B now. Question B states here, determine a Cartesian equation of the plane that contains line, what line? Line L and is parallel to line M. So a plane that contains one line is parallel to the other one. We've got line L and we've got line M, and our plane has to contain line L and be parallel to line M. So the plane we're looking for, it's a bit difficult to see, but the plane we're looking for is this one. Okay, this plane here. And we know that M is a line that is parallel to our plane, which means that the distance between M and the plane is constant. Good. So what do? We need to find the equation of a plane pi, again, pi 2 if you want. For finding the equation of a plane, we need to have either the normal vector and a point. So we need the normal vector of pi and a point. And for this, we just need to find two vectors that are contained in the plane. We know that the plane pi contains line L and is parallel to line M, which means the direction vector of line L and the direction vector of line M are contained in the plane, and therefore the Cartesian product of these two vectors will give us the normal vector of the plane. So how do we do that? For finding Cartesian product, the cross product, Cartesian product of two vectors, first we need to find the vectors, and the vectors we've got are one of the vectors is 1, -2, 3, and the other vector is 2, 1, 0. This information is given here, 2, 1, 0, 2, 1, 0, and where is that given? 2, 1, 0, we just found that out here. 2, 1, 0 is here, and 1, -2, 3 is the direction vector of line L. So when we've got these two things, we need to find the value of the cross product, Cartesian product of these two vectors, and using the calculator, cross B, and inserting both vectors, we just get that the normal vector to the plane we're looking for is 3, -6, -5. Our plane looks like ax plus by plus cz plus d is equal to 0. And this thing here, which is the normal vector of pi, is basically a, b, c, which means that our plane at the moment looks like 3x minus 6y minus 5z plus d is equal to 0. Now we need to use a point that lines on the plane, which means that it has to be a point that lies on L, go up, 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 point that lies on L, 0, 1, 2. We insert the coordinates of 0, 1, 2 here, and we just get 0 minus 6 minus 5 times 2 plus d is equal to 0. Therefore, d is equal to 16, which tells us that the equation of the plane we were looking for is 3x minus 6y minus 5z plus 16 is equal to 0. And that's the equation of the plane. If we want to elaborate a bit here, the step of the cross product, the way to calculate the cross product is using ijk. We find the value of the determinant, where we write ijk on top and the two vectors we've got. And then when we find the value of this determinant, we get the coordinates of the vector. This is 3i minus 4k minus k minus 6j, which is equal to 3i minus 6j minus 5k, which means vector 3, -6, -5. And with this, we're done with the test.